So, in the previous part of this episode, we have talked about how expressions represent calculations that you will do later once you find out the values of all the unknown numbers in your situation. Now, suppose that, later has come, and now we do know the values of these unknowns. We do know the values of x, of L, of t, of s, whatever. When you finally figure out the values of your unknowns, and you are going to calculate and perform the calculations in the expression, that process is called evaluating the expression. Perform the calculations in the expression now that you know the values of the unknowns. This process of evaluating, this process of performing the calculations, now that you know the values of the unknowns, this process is often referred to as plugging in values in the position for your unknowns. So someone says evaluate the expression point 2 times x, because now I know the value that x should be equal to. X should be equal to 4,620. So I'm going to perform this calculation, point 2 times x, except now I'm going to replace the x with this specific value that it is equal to. Point 2 times 4,620. Actually, I don't like the two dots, so let me write it like this. Point 2 times 4,620. And in a calculator, for example, this would be the specific number 924. That would be the result of evaluating this expression now that I know what x is equal to. The result of this calculation, when the x is 4,620, the result is 924. Someone says, I wrote the expression 2 times x plus 3 to represent the action of multiplying the unknown number x by 2 and then adding 3 to the result. Now I know that the specific value of x is minus 1. So now that I know the specific value of x, let's go ahead and perform these calculations. So now it's 2 times minus 1 plus 3. 2 times minus 1 would be negative 2, following PEMDAS, doing the multiplication first. And negative 2 plus 3 would give me 1 as the result. So 1 would be the result of plugging in x equals minus 1 to this expression. Now, from time to time, you will run across an expression where there are multiple copies of the same variable in the expression in different places. If you're in a situation like that, and you're evaluating an expression like that, just be careful to replace all the copies of that variable with the given number. So for example, someone says, okay, I had a number x and I did not know what the number x was, but I wrote down this expression to capture some instructions and some calculations that I'm supposed to do later once I figure out what x is equal to. Now I know that x is equal to 5, so let's finish these calculations. So I'm going to go into this expression, and everywhere there was an x, I'm going to replace that x by what I now know, x is equal to 5. So in the numerator, I have 5 plus 1. In the denominator, I have 5 minus 3. And so now that I know that x is 5, I'm going to complete these calculations. Now, following PEMDAS, there are hidden parentheses in the numerator and the denominator. So this is going to be the same thing as 5 plus 1, 6, all over 5 minus 3, 2. And 3 divided by 2, 6 divided by 2 gives me 3. So 3 would be the result of evaluating this expression when x is specifically a value of 5. Now, a special warning, specifically if you're dealing with values that are negative. If someone writes down evaluate 5 minus x, take 5 and subtract x. I now know that x is equal to negative 7. So what I want to write down when I plug negative 7 into this expression is 5 subtract negative 7. To write that in symbols, I would write 5 minus negative 7, but don't forget that we don't like to have a minus sign and a subtraction sign right next to each other. I would put the minus 7 in parentheses to say 5 minus negative 7. Once that is done, I can finish the calculation either by hand or by a calculator, and I get a result of 12. So 5 minus x becomes 5 minus negative 7, which is symbolically written as 5 minus parentheses negative 7. Another example where you have to be careful with parentheses and negative values is if someone says evaluate x to the power 2, raise x to the power 2, square x. Square it specifically when the x is negative 4. If in the original expression my instructions are to square x, if x is specifically negative 4, then I need to write something down that will express square the quantity negative 4. Now, you may remember from episode number 3 that when we were squaring negative numbers, when we were raising negative numbers to powers, we had to be really careful about our notation. If we just wrote down minus 3 and put the power 2 on it, then in this symbolic notation, only the 3 directly underneath the exponent is going to be raised to the power 2. So what I've written down here with no parentheses is not going to square negative 3. This thing is only going to square the 3 and then put the negative sign on the result, the answer to that. If I wanted to say square minus 3, I had to put the minus 3 in parentheses and then apply the 2 to that quantity. And so I'm going to have to do the same thing down here in episode 12. If I want to communicate square minus 4, I have to put the minus 4 in parentheses and apply the 2 to that entire quantity. I cannot get away with negative 4 to the power 2 because this is not going to square minus 4. This is only going to square the 4. If I want to square the whole quantity minus 4, I have to put the minus sign in parentheses. And that's going to give me the answer in the calculator of 16, whereas this one is going to give me an incorrect answer in the calculator, negative 16. That's not going to be quite right.